12 most likely that you're going to see, and I want to go over it, and it looks like it's so complicated, but of course it's period 2. We're not period something else, and we
Please
can
don't tell me
use
it's number 7.
Pardon me?
Please don't tell me it's number 7.
No, it's number 2.
Okay. Oh, I didn't get that.
Number 7 is somewhere else. I saw that too. Yeah. Okay. All right. So I'll hopefully copy this correctly. You guys can tell me yes or no. So it gives you something like this. Okay. So 24 sine of theta minus 7 cos of theta. Right. Gives you something like this, and it wants it in the form of r. Right. Sine here, and then it says theta minus alpha, or a minus b. And it says, hey, r is greater than 0, great. And then the angle exists between 0 and 90 for just alpha. Fantastic.
Yes.
Find alpha. So what in the is going on with alpha? Okay? You're like, oh my goodness, I'm skipping. No, you're not. You're not going to skip anything. You're going to do them all, and then you laugh at me. It's a test. Okay? Make sense so far? So to speak. Okay? Okay. Not bad? Everybody okay so far? Yeah? Do I have? I am doing the monster packet. It's October, November 2012.
Onomatopoeias on the front.
Onomatopoeias.
She's thick.
It's the monster packet. It's not the homework. It's not the homework. Okay?
Yeah.
I will go over the homework very closely.
Sugar astro.
Yeah, it's like it has meows. Yeah, I have a lot of them because I want you to practice. It's the only way you're going to get good at these, all right? Okay, so when you see this one as such, right, I have a whole bunch of stuff on it. I hope you really look at it. I know, it's unbelievable, right? But what you see some of these, now watch your eyes, okay? This is just to show you what's going on. This is the notes that I made from the book. Now, it looks awful and whatever it is, but it's the same thing. This is the sine of alpha plus whatever. You also have the one that's minus. And we're going to use a formula to figure out what's going on when it comes to this r, okay? R is just the hypotenuse, so to speak, okay? That's all it's asking. And then we're going to find the angle that's associated between those two legs. All right? Not bad? That's what it's asking. All right. I really, really strongly say, please look at this, all right? It's online. Hey, I didn't just do it for my health. Well, maybe me, right? But I went over the Cambridge book and saw their errors, of course, and I had to set them straight, so to speak. But that's me, all right? Okay, so that's where it came from. I have pictures of that as well. So the first thing is you say, oh, well, we're going to say 24 sine theta minus that 7 cos of theta. We're going to say it's somewhat equal, if not absolutely equal, to r, sine again, of theta minus alpha, right? Not bad? Not bad, right? Now, you have a formula for this sine alpha minus whatever, a minus b, a plus b, whatever. That's on your good old Cambridge sheet. You don't have to memorize it, you just get it, all right? So, the first thing is we're going to leave the left-hand side alone, and we're going to expand this wonderful thing, okay? Remember, this is just no different than a minus b, okay? And if it was cosine, you do the same thing if it was cosine. However they want the sign, right? So, what do? Well, we love this to you, Murmer, at least for 35 minutes. Yeah, that's true. But you go, I couldn't help myself. R of sine. Now we're going to expand this. Now that means you don't put excessive amount of stuff here, right? It just means that you're going to expand it using the formula, right? So it's going to be r sine theta. This is just from the formula. Cos of alpha. I'm getting it from the formula, okay? Minus r cos of alpha. Theta. Sine of alpha. Okay, that's just from the formula. It's like A and B, okay? That's all it is. It's A and B. All right, give me a second. Give me a second. I know. What? Not bad? So that's me, right?
That's just the formula.
Yes, ma'am. That's all it is. This is no different than an A minus B on your sheet, okay? Not bad? Says me, right? Well, now we're going to set some things straight, so to speak, okay? Well, we're going to say, for example, the alpha, right? The alpha parts. We're going to say that that's going to be just the, what here? So we're looking for cosine of alpha, right? And when I look at this, and I can't remember, they just gave it to us, there's a rendition of it. So when you see, you want to get cosine of alpha here, okay? So I'm going to say r cosine of alpha is equal to just one of these. It's always the opposite for some reason. And if I just divide by something through, I get the number that's the R here. See the R and the R? This is an R, this is an R. Okay?
Wait, what?
Go ahead. Those are legs, so to speak, right, of the triangle. Cheesy picture. Wherever the triangle is, it's a right triangle, of course, okay? Or, I'd like to say it, we're trying to find out whatever that angle is, okay? We're trying to find out good old alpha. All right?
Of course.
Of course. So, in order to find alpha, they give you the two legs. And then they give it to you as, quote, R, right? Does that make sense? They give you this guy, and you've got to find out, let's call this big R. Right? Big R. Yeah. Right? Now, to find out the sides and so on, right? Well, if I knew what R was, whatever it was, I would know cosine of alpha and cosine and sine of alpha, right? So the cosine of alpha, because that's what they want, right? Hey, they want alpha, right? Yeah. So that means I could just set cosine of alpha equal to 24.
Why?
Why?
There we go. Why?
I know that.
I missed one day, I don't know any of this.
I'm going over it right now that you didn't miss any of it, okay? You didn't miss any single thing of it. Well, I'll tell you in a second, all right? So when I expand this thing and start dividing stuff out, I will get, remember this is over also here, right? 24 sine theta minus 7 cos of theta, right? I think so. So when I divide out the sine thetas, right? Right? If I divide everything by sine theta, I just divide this by sine theta, then what happens?
Cancels out.
Cancels out.
Don't you divide?
Then I get r cosine theta equals 24.
Don't you divide
You have to
the
divide.
7 by cosine?
What about the other ones?
I mean, sine.
It won't matter, right? I don't care. Well,
Why won't it matter? Because
won't.
24 minus 7 then.
right, but I have to separate it by getting each of the individual sides, right?
Wait.
All they care about
Wait.
is,
Yeah.
go ahead.
Mr. Murmer, so
Go ahead.
those on the right side, those
On
are
the
the
right
two
side.
legs. It's completely equivalent to the two legs on the left side.
Yes,
So it's corresponding terms based on the position in the equation.
Mr. Tribble beat me to it. Okay? Mr. Tribble beat me to it.
The 24 sine
Go
theta
ahead.
corresponds directly to the r sine cosine,
Oh,
and the 7
so the
cosine.
7 has nothing to do with it.
Yeah.
Not yet, right? Because the 7's going to be the sine, right?
Yeah, but why are we dividing by sine theta?
So we can.
So I can get you the side.
Yeah, because you have to have a number there.
Got to have a number there, right?
Oh, so we're getting rid of the r cosine sine on the other side too.
There she goes.
Um,
Didn't I have? I got to make you so much struggle, right?
Yeah.
Because if you don't look at it, you're going to go, oh, well, oh crap, Murmer's on here, right? I can't have. I want to be there, right? But I'm a big enabler, so I can't do it for you. Okay? And I love it when you say that. So, Mr. Tribble, why on earth did you just do that stuff? And why isn't it? Why do we? How did you get 24 to be r cosine theta? Take it away.
Divide the sine out.
Yeah,
Isolate. So you can solve.
that's correct. But what happened to the 7 there, right? Does that
So
matter?
That doesn't matter because we don't care about.
Because you don't care about it, right? Because what are you looking for?
We're just
Alpha.
looking for alpha.
Alpha. Right? Elbow, alpha. I tell you, I work at a dog for a dog food company. Did I tell you that?
You've
Yeah.
been telling us this for 3 years.
Good help myself. Is that alpha, yeah, never mind. You get so all we care about, Mr. Dribble, is like, I don't care about sine, theta. Who cares? I want to get alpha by itself. Make sense?
Yeah.
All right. So to speak, of course it does. Now, the next one. Can someone tell me, well, if that's one of them, how do I get the other guy then? Well, it's going to be r sine alpha equals, well, you divide by sine alpha all the way through.
Negative
right?
7.
And it's going to be 7.
Or, yeah, 7.
Yeah. Now the thing is you don't have to worry about this quote sign that's associated there. All right.
So we're dividing by cosine theta now?
Mhm.
Both.
Then you divide by cos theta, right? Cos.
So we get,
We don't care, right?
is
Cos.
it negative 7 equals?
Yeah. But it doesn't really matter because what's our domain, right? Right? What's our domain? I told you, I gotta have you so much struggle. So you see this go. Oh, okay. All right.
Huh?
Go ahead, Billy. Yeah. Yeah. I'm listening. All right. Yeah. Yeah. All right. Now, what's the next victim? Well,
It's because of this.
now I got the legs, so to speak, right? I got the legs somewhere, right? So if I don't know what r is yet, right? But I know the cosine of alpha is opposite, whatever, right here.
Adjacent over hypotenuse.
And then sine of alpha is that guy right there, right? Just to show you a little picture. That makes sense? Right? Remember, cosine of alpha is what? Opposite over, adjacent over hypotenuse. Adjacent over hypotenuse. And then alpha again here is going to be opposite over hypotenuse. I just didn't throw it over there, right? Because I don't know the value yet, right?
No.
But I'm going to get that to you in a second.
Isn't there substitution or something?
Well, no, don't do any more. What's this thing right here?
Triangle.
Yeah, that's right. And the triangle, that's a right triangle. Oh, gee whiz.
You see,
Oh, so you just like backwards proved it. Okay, that makes sense.
I actually did the corollary of the Pythagorean theorem. Yeah, get out of it. All right. How do I know? How do I know where 24 and 7 go? Right.
No, how did you just get the triangle?
I just made the triangle. I just do
Is it
that.
anytime we do a problem like this?
Yes. There you go.
wait, how
There
did
she
you
goes. Go ahead.
know which side was yours?
That's a great
Because-
question. Okay,
Yeah.
Mr. Nick,
Did
take it
that
away.
Alpha?
So, like, if you divide by r, you've got cosine alpha equals 24 over r. So cosine is adjacent over hypotenuse. So if you find alpha, then you say, what's adjacent, what's the hypotenuse? And then that's how you
But I
come
don't
up
know
with
what R is. So what the R is going on, right?
Yep. So now you just do 7 squared plus.
There he
Yep.
goes. R is equal to the square root of a squared, b squared. So I'm going to put 24 squared there plus the 7 squared. Okay? And everybody knows 24 squared is 576, right?
Yes.
Of course, plus 25. And then I believe so.
It's
49. And so I'm ahead of myself. That's
So you
625.
should do 24 square feet.
You're 24 squared, but 7 squared. You're like, it's 24.
I'm sorry, it's a Pythagorean triple.
Yeah.
It is
Yeah,
7.
Oh,
Yeah.
yeah.
Why is it a triple?
Because it's perfect.
That's true, Mr. Tribble. Absolutely. It's because it's what? The common denominator between all the three legs, the 2 legs and the hypotenuse, is only divisible by 1.
Yeah.
That's why it's triple.
Yeah, it's a whole.
3, 4, 5. 6, 8, 10 isn't because I can divide everything by 2.
Uh-huh.
Okay? Yeah. All right. Yes. Leila? Not
Bella.
Bella. Sorry, Bella. I couldn't see it
Yeah, I'm blind.
because she's like doing this.
Did you forget your
Mr.
marbles?
Appler.
So this problem actually was on the homework, and I was having trouble with it. So now I can do it.
Yeah.
So
Yeah. You like it? Did you see? Yeah.
Yeah.
Okay. I know I got to go over it. I know you got to like.
Wait, now we have to find alpha. don't we?
Yeah. That's get going, Murmer, right?
Yep.
So alpha, how in the we're in the alpha's going on here, right? This is 25, right?
You just plug in the
You can find
R.
alpha any way you want, right?
Yeah.
But let's say that you didn't know anything, but you can still get alpha and the points, right? But if you put these in the right place, which you should be able to, and you let's say this said this is 10,000 or something, which you didn't, you can also say what? There's also sine, cosine, and their other buddy,
We could apply.
Tangent.
tangent, right?
Yeah.
Tangent. Doesn't matter which way you do it, right? Pardon me?
You could just use
Because
whatever
we have
you
like,
want.
You can use any cofunction you want.
so we have 7 equals r sine theta. We can plug in the r and then solve for theta.
Oh,
Yep,
yeah.
yep, again, right? Okay, moving on here, right? So you guys can say, yeah, I can find sine alpha, whatever, right? And I can also do cosine alpha, whatever, right?
Yeah.
Right, and find the alpha guy, right? But I'm going to do tangent of alpha. Why? Because I want to, right? The biggest thing is because I have both of those sides. The ratio sine over cosine, right? And if I made a boo-boo, like making this guy, it's going to affect the angle. Does that make sense? But now I look at this and go, well, the ratio of those two monsters, sine over cosine, 24 over 7, right? Or, opposite over adjacent, right? And that's going to give me alpha of to be what? Tan minus 1 of what? And you give it to me in degrees, right? Because it's from 0 to 90, right? Roughly.
What is it?
I don't know.
We didn't even have to find R.
No, we did. because
Oh.
we
You did. You had to. I'll show you why. Okay? That's why you want me to do one of these pieces, okay? 16, that's right.
6.
Roughly 16.26, right? All right? Make sense so far?
You could have just plugged in the equations you found already.
Yes, you could. But we're doing Cambridge. Yes, you could. Very clever. Okay? I'm trying to get you every single stinking point possible, okay? So you know what's going on. All right? I know that this looks... Once I do one, they're like, magic period 3, okay? I mean, they're going to get it. they're just going to be more vocal. All right? You guys are like, ah.
Wait,
See? Yes?
back up at the top, you say cosine of alpha equals 24 over r, and then sine of alpha is 7 over 24?
Well, cosine of alpha is going to be 24 over 25, and sine of alpha is going to be 7 over
But you wrote
25. Thank you. Thank you. She got me. She got me. Keep me honest.
was
Remember, I saw something about Uncle Sam, so you know what that means, right? Say Uncle Sam a couple times to your parents, they were like, they're thinking you're bagging on the government, okay? All right, so I got that guy, right? What else do I got to get? Well, I don't know. Well, I got alpha. I got 3 pesos, right? Now I got to find out what on earth, how I get the next guy, right? Double I. Yeah? Uh-huh. Okay. Everybody okay with this? Thank you, Mr. Tribble. Okay? I always like that song, Lean on Me. Okay? You ever hear that song?
Yeah, I hope
I
so.
hope so, too. And I like the song that they did from Diablo. It's not Diablo. Is it Diablo? No, it's not. It's Dante's. It's a game. And they go, Ain't No Sunshine. Yeah. Yeah, Jason Smurf. Yeah. Show my age. All right. Any questions on this, please? Billy?
So why do we do tangent
what?
alpha?
Pardon me?
Why are we doing tangent of alpha? Oh, because we need to find the angle.
We just
Yeah.
can. We
You can use any one of those 3.
Okay.
Because we know.
But I just used this one here because I could have made an error with the R, right?
Yeah.
Doesn't matter. They don't care. I don't care. All right?
Oh
Okay?
yeah, you don't even need the.
Yeah, see how fast? See how you're streamlining it, okay?
Wait, so you don't need the R?
No, because you could do tangent.
Well, let's see, right? Let's see if I can figure this thing out, right?
Yeah, I don't think
Okay.
we need it.
I gotta still do the other bottom part, right? Double I. Everybody okay with this?
Couldn't we?
Could we do what?
You could have gone the first part without the
You
R.
decide the closest.
Oh, I did it with the R. That's just me. Okay. So if I wanted to put all this together, ladies and gentlemen, hold on. If I wanted to put all this together, I would have 24 sine theta minus 7 cos theta, right? Equals 25 sine of theta minus, what's the degrees for alpha? 16.26 degrees.
That took so much
Okay.
power.
Make sense so far? Yeah? Okay. Now, this leads into double I, all right? Everybody okay?
Mr. Murphy.
Mr. F.
So why instead of saying 17, you say
17?
that stuff?
16.26? I don't know.
Oh, because they were. I'm just looking at part
We
double
wanted
I.
to do decimal places, sir.
Yeah.
Okay? All right, can I go to the next one and then we can do an evil homework?
Yeah.
Yeah, exactly. All right, moving on. So, please underline this, even though I wrote a line over it. All right? Put that, so I'm going to write this again, all right? So here we go, double I. Double I says, hey, what? Here's 2 points, you need 2 points to live. No, you 24 sine
That's the difference between
theta.
passing and failing, because that's how I pass.
See what I mean? So Billy's like, man, I got to get this one right. I'm like, Billy, you're going to get it. Okay? Now, they're going to say, hey, find the smallest positive value. Remember a long time ago in a galaxy far, far away? Remember this one?
Mm-hmm.
Yeah.
We just
Hold on. You're ahead of me as usual.
smallest value of theta.
Hold on. Remember, Cambridge likes to build on stuff. All right? All right. Michael already did it, I can tell, huh? It's like, yeah. You see it? Do you see it? Okay, that's all right. Watch this.
They want us to substitute something.
Oh my goodness.
What are we substituting?
I don't know.
Well, that's equal to that, so put that there.
Oh!
Okay, I see.
See how you see it?
Yep.
I'm removing the green
Sine
curtain.
theta minus sine cosine.
Okay, so one eyeball, right? Eyeball builds upon double eyeball, or double eyeball builds upon eyeball, right?
Yeah.
Yes, and go ahead.
We should call this a trade-in problem.
The trading problem.
Yeah.
Yes. This is the.
Don't we just plug it in?
Yeah.
Just plug in
Yeah.
something.
Yeah. Okay.
Yeah.
All right. So I have no idea how to do this, right? But I can substitute my previous stuff into here. Is that okay?
Yeah. I
Yeah.
thought you had already substituted it.
I
know
didn't
you
yet.
wrote it and were
I
about
told you
to
to.
substitute it. So I looked at it like, what did you swap?
Remember, these two are equivalent, right? Yeah.
Yes.
Now divide both sides by what? 25. I took away the chicanery of it. Yes, hold on. Now, how do you do this thing? Oh man, Murmer, hate you. All right, well, I'm going to show you, all right? Now you take the sine minus 1 of both sides, right?
Yeah, and then you just.
There you go.
17,
Well, look at this.
16.
Look at this. That's why I belong doing this stuff, okay? This is sine, hold on, minus 1 of 17 over 25. All right, Katie, go ahead. Never mind. So you take the inverse of both sides, right? Oh,
Yeah.
it's a little bright light, okay? Now it's cake. Now someone's going to tell me what sine of 17 minus 1 of 17 over 25 is. That's a reference angle. This is between, remember, oh man, Murmer, you told us this again and again. I know I did. 42 and
42.8.
change.
Yeah.
42.84.
Yeah.
Now, theta minus what? Mr. Joe's like, well, don't forget the 16 and change. You're ripping me off, Murmer. Yeah. If you're not going to pay attention, I'll rip you off, right? 16.26, right? Boom. Theta is,
59.1.
look at her go.
So we have to
Meow.
do the arc sign before we add the.
Yeah, but
Yes. Yes. Katie.
Because if you add it first, you're not going to get that number.
No, you're not going to get nothing. All right?
This is cake.
I've been teaching trig for 100 years.
Oh,
Okay? Go ahead, Katie.
No, I got it.
I know you do. M's over there. Cammy, all right? All right. Bien, see? Did I say it right?
What you confused me with, it was the first part where you.
How do you get the sign?
Where you expanded, because I was like, where did this huge thing come
It was
from?
the
What
trig identity.
It's a trig identity, right? I know. I did it somewhat intentional. It's like an intentional, unintentional walk, that type of deal. I have to show you.
But I just.
I believe that this class needs an extra hour a day. That's my opinion.
I'm getting that.
Well, yeah.
I know, it's going to be great. Oh, I can't wait. I'm ready.
Yeah.
I'm really ready for it.
I'm
We're
ready.
having Latin for 30 minutes.
Oh.
Okay.
30 minutes.
Extend,
Yeah,
right?
30
All right, not bad, guys. Not bad.
Let's get a minute.
It's palatable, right? You can do it. You can salvage points and everything else.
Yes.
My goal is to get you past that test. That's my number one goal. Whether you have whatever grade in this class, that is what I say. That's my goal. I want to do, and I need time with you guys. The upper echelon or wherever. I mean, you're already in the upper echelon anyway. Okay, 75 kids, less than 34 kids out of 1550 is the major body, right? And how big is your graduating class?
347.
347. So take Billy, take 347 and divide 34 divided by 347. What'd you get? Like
34
little,
divided by 3.
yeah, 34 divided by 347.
10.2.
So you guys are 1 out of 10 minimum.
You're not counting some of the kids that are ahead of us, though.
I'm counting some of the kids that are
Because
ahead of
there's
you.
like Saba and some people who took this class last year.
Oh, so it's even less. 1 out of 5 maybe. And that's just in your graduating class.
She's at Eastern Florida.
Okay,
She does the collegiate.
41st.
And she early.
Yeah, the 300 something. All right. All right, ladies and gentlemen. Anything else on this one? Please practice this one. It's easy for me to go, talk like the peanuts and dust, but you should take it and do it again. All right? All right.
She's going to Duke.
All right.
She's going
Go
to
Duke.
Duke?
I think.
Blue Devil.
Are you serious?
All right, now I'm at your disposal.
Harvard?
No, it's like Smith or something.
I got a long time ago. I think at 17 I was accepted to Columbia.
Both of them.
Yeah, I was.
I don't know.
All right.
I remember having science with her.
Guys, I got a question. Okay, this is another thing that, ladies and gentlemen, this is another thing that they like to do. If you see this triple equals, use that to your disposal. This says, hey, you might need either one of those sides to be compatible to the next problem underneath it. You okay?
Okay.
I wish I had another week just to dissect what these guys are doing. Because you would be like, this is nothing.
Shall we move on?
Yes,
to
we
the
will. Go
next
ahead.
one?
Yes. Which one would you like? Okay.
Number 1.
Number 1?
We did.
I thought we did number 1. Did we finish number 1?
We have it for you.
You're okay with number 1?
Yeah.
Does the Dunkin' Donut crowd have it?
Excuse me, what? Dunkin' Donuts
Where the
is Arby's.
Arby's?
Oh boy. Uh-oh. Wow. Wow. See what
Okay,
happens?
because at the end of the year, we need 13 people to hike their way over their butts over to Arnie so we can take the final supper.
Take the last
Supper of the, yeah, beautiful. Beautiful. Now, number 2, guys, look at number 2. Now, I might not do it or do whatever. Is it nearly the same thing that I just did?
Where's number 2?
Number 2 on the homework, hon. Sorry, on the homework.
Yeah.
Yeah.
Okay.
Just
The one-
different numbers.
Yeah, I know it's confusing numbers, but it's just me. It's October, November 2011, 33, right? Does that look really familiar now, Nick? Can you
Which
tackle it?
October, November 2011, 33?
Yes. Yeah. Doesn't that look really familiar? It's $7.
Yes.
Why is this
I was struggling with that, but now I
Now
can do
you're
it.
like, oh, that's it.
Yeah.
Right? You see it?
Get it?
All right. Okay. I have no problem going over that again, but someone says, hey, they probably want me to do like number 3, which is 2 points, two big guys, right?
On the homework.
On the homework. Number 3 on the homework. Guys.
Our number 3.
Our number 3. Is that okay? You want me to try the one? Ryan, okay on that one?
You mean the number 3 on the second page?
Whatever page it is, yeah.
This
That's
one.
number 2.
Okay.
Made you
Okay, our number 3 or their number 3?
our number 3.
On the second page.
Yeah, see it has 3 and 4?
This
Yeah.
one?
Yeah, it has like that equal sign thing, whatever.
Is that, how can I know it's 1 problem?
It says yes, I did double. I did it for you. Yes, I know it's terrible. It's awful. I don't know how I can live with myself, okay? All right. All right. So, is it okay to continue? How much time we got?
Like, took our time.
We got lots of time.
We got time.
10? All right, we can start it, right?
Yeah.
All right. So, ladies and gentlemen, okay? You're going to thank me later. If they give you that R stuff, you're going to laugh. You're going to absolutely, I mean it. You're going to be like, oh, God, please. All right, so they're like, Murmer, get on task, like Emmy says. So, May, June, 2013, 33. Agreed?
Yep.
All right, let's try number 3. 3 for 3, yes?
Yeah.
That's not bad one. Okay, so it says, hey, how you doing? Tangent of 2x equals 5 of the cotangent of x. And it wants it from 0 to pi or 0 to 180. All right? You guys are pretty, you guys are good at trig. I can already tell. All right?
We've been doing trig for 3 years.
Exactly. So it's like, yeah.
I hate trig.
Oh, I've been teaching it for 1,000. You know, it's just, you know, but you get the idea, okay?
You've been doing trig for 3 years. Yeah.
Nice for you guys, right? I think I also did trig with you guys since Passmarks, right? I have the old sheet that she had. She just like, yeah, whatever.
I remember doing those worksheets and nobody getting them. I was the only one that was walking around. I didn't
Not that
stand up
bad.
and just show you how to do stuff.
So, there's a double angle and there's an inverse guy, right? Or a reciprocal, right? Okay. So, in order to do this one, we have to manipulate all these, yeah?
Yeah.
Because it's not an identity. So, thank you. Is there a 2x, a double angle that we can replace tangent with? Anything. Tangent of 2 theta, 2x, 2z, 2a. What's the formula
Yes.
for that guy?
It would be 2 tangent x
There it
over
is.
1 minus tangent
There
squared
it
x.
goes.
It's on the formula sheet.
There you go. Okay?
Tangent 2 theta, or 2x.
Correct.
Yeah.
So I replace this. Why would I replace a double angle with this ugliness?
It's easier to work with.
It's easier to work with, and also it's singular angles.
Right.
Is that tangent squared?
Yes, ma'am, it is. It's just hard for me because of my hand. Yep. They did a study on people's handwriting. They said the worse the handwriting, the smarter they are. I gotta, of course, yeah, exactly. Yeah.
Mine is garbage.
Yeah, see, there you go.
And I'm
I can
left-handed.
barely write. But I was writing with my right hand. Right?
Left-handed.
All right,
Same
moving
thing
on.
also.
5 over what? Cotangent is what?
1 over tan.
1 over tan. So I can just say tan of x here, right?
Yeah.
Pretty cool? Everybody okay so far? Remember, this is Cambridge. This is in your mind. Okay?
Crisscross applesauce.
Crisscross applesauce, because it's a proportion. A times B equals B times C. Yes, correctamundo. You get 2 tan squared x equals
5 minus 5 tan
5
squared.
times the quantity, 1 minus, and you can do the distributing, right? But I'm going to show every step because I like to. 5 minus 5 tan. You guys help me out. Squared x. Boom. All right.
So we have tan squared x on both sides.
You're correct. Now I like to get my tan squareds or whatever it is
Together.
of
So
course.
seven
And I'm going to,
tan-
yep, she already did it.
7 tan squared x equals 5.
Look at her go. Okay. And then I move the 5 over, okay? Or I don't have to, right? Because, yeah.
You can make it equal 5.
Yes, I can, yep, tan, so I got 7 tan squared x equals 5, right?
Uh-huh.
Now, not bad so far?
Yep.
Now, divide both sides by?
7.
Tan squared x equals 5/7. Well, everybody knows what 5/7 is a fraction, don't they?
Nope.
5/7.
What?
I don't know my 7.
Hold on, divide by 7, right? Hold on. I'll get it.
0.714.
0.714285771482557. Yes?
7142857. Yeah.
142. It keeps repeating.
Uh-huh.
Yeah. Indefinite. Okay. Now, I do what now here? Remember, it's a singular angle, though the cofunction squared. So therefore, I do what? I square root everything. Yes?
Yes.
Okay.
That's not what I was going to do. I was going to do something way more.
Now, you could have substituted some stuff in there and everything else, but make life easy for yourself, okay?
Yep.
All right? Because you got a time limit. It's like Independence Day, the time's ticking.
5.
So, tangent of x equals what? Plus or minus the square root of 5/7, right?
Yeah. Or 0.8452. Really want to get complicated.
Okay, yeah. So, x equals tangent minus 1. And remember, we're going to do the base angle, right? And we can do a couple others, right? So we're going to do the base angle. Is that okay? Square root of 5/7. And that equals approximately what, ladies and gentlemen?
40.2.
40.2. Okay. That's the reference angle. I call that the reference angle. You guys are pretty good with that one, right?
Mr.
Now,
Murmer.
here we go. Yeah?
So
Now,
yeah,
go ahead. You're already doing it. You're already doing it. Yep.
I did the quadratic formula for this.
Sure you can. Absolutely. Absolutely you can. But I'm lazy. Because I didn't have a middle term, right?
Right.
The middle term canceled out, so I don't have to do it. You're fine with that as well. You can complete the square if you want. Absolutely. Okay, so I got this guy right here, right? Whoop. Hey, I'm 40. This little theta guy or this x guy is 40.2. Now, it says from 0 to 180, right? So, what other angle does it want? Well, it wants this guy over here, right? Make sense? Doesn't it want that other guy?
Yes. It wants it in
does.
both quadrants.
Wants it in quadrant 1 and quadrant 2. Why? Because it's on top. I call this the top. Oh, look at. Oh, look at.
Again.
See him? You didn't see him, did you? You didn't see him, did you? So, you saw him, did you? He's always talking to me. So, this guy here is theta, or x. This one is 180 minus x, right? So that means the angle's going to be what for the other one?
180 minus 40.2.
And that answer is?
Something.
And I'll help you out. 139.8.
139.8.
Guess what? You just got $5.
Yep.
Pretty cool?
Yep.
All right?
Alright.
All right. Not bad. Do we have any more time? No. I wish we
When
did.
when you mentioned Independence Day, like the movie, it reminded me when I was younger and I saw that movie the first time. My dad convinced me that was like the actual Independence Day. It was a